All right, so let's go ahead and start. So welcome to CAPACiTY. This presentation is on authentic social justice via culturally relevant CS. And I'll just go ahead and introduce myself since I'm already talking. I'm Pam Whitlock. I'm an AP Computer Science teacher in Fulton County Schools. And I'll let Doug and Diley introduce themselves and then continue on.
Hello, everybody. And we did that at the same time, of course. You go ahead, Doug.
Doug Edwards. I'm a co-PI on the CAPACiTY grant and a senior research associate scientist at Seismic. Been at Seismic for the past 10 years at Georgia Tech. Previous to that, I was a high school math, engineering, and computer science teacher, and previous to that, an electrical engineer.
And hello, everybody. I'm Diley Hernandez. I am the CAPACiTY Program Director and a Senior Research Scientist with Seismic. My background is in educational psychology, especially at the study of motivation and cross-cultural studies in education. Thank you all for coming today and being here and listening to us present the curriculum that we have available for our CAPACiTY program.
And I'm sorry, I was going to just say Gloria Bates was part of developing this presentation. Since we're restricted to 3 presenters, it's just us 3.
So the first thing that we wanted to present to you, it's a little bit about our CAPACiTY framework. So our project, has been funded by NSF. It was an STEM-C NSF funded project that started about 4 years ago. And we initially, our initial works pretty much focused on the development of the Introduction to Digital Technology course. Pam, if you can move to the next slide. When you actually, something that we noticed when we looked at the state of the high school courses and the progression that students were able to do within computer sciences in high school, something that it was very glaring to us was that there's in general a low enrollment of underrepresented minorities, especially female, Latino, African American students within those higher level computer science courses. And so we wanted to sort of design an introductory course to Introduction to Digital Technology, which is the first one in a series of courses that students take in a high school that would not only be rigorous in terms of computational thinking, but that would also motivate students and engage them in really meaningful ways and get them excited about the opportunity of taking computer science courses later on in their progression and consider computer science as a possible career. So that was initially the primary goal of our grant. As we are going to be presenting today, after we developed our first course for IDT, we actually saw an opportunity of using the same framework principles that we have used in the development of that Introduction to Digital Technology course and apply it to other courses, extend it to other courses like the Middle School Foundations courses and also APCSP courses. So today we're going to be talking to you a little bit about how these different courses look like using a CAPACiTY framework. So the first thing I will do now, it is just to tell you a little bit what is that framework that we use in our CAPACiTY curricula. And if you can move to the next slide. Thank you. So first of all, a big part of our initial work was to look at existing standards that were available for the design of these courses. First of all, we looked at, of course, at the Georgia IDT standards when we were designing the IDT course, the Exploring Computer Science, the ACM K-12 Computer Science Framework, and the CSTA revised standards. We also did some classroom observations in classrooms and with our partner districts. And we sort of like index a potential amount of topics that were generated that could potentially fit in within all this, within that IDT course. And as you can see, there's a wide range of topics, standards, and things that we could have been able to incorporate within the IDT curriculum. But something that we wanted to do was just to really think about instruction in a way that was highly engaging for students. So, we can take all these standards and still have an instruction that is very much teacher directed, and that it's not as a student center as we wanted to do it. So, in terms of how do we teach then computer science in a way that is motivating to students, especially those who do not see themselves within these fields, we started developing certain principles for our design that were sort of like the core of our capacity curriculum. If you can move to the next slide. So first thing is that, like I mentioned, we wanted to have a focus on computational thinking. We were looking at existing standards and trying to select those who were not only rigorous, but would give a student sort of like a very good flavor of other sort of like potential courses and content that they could see later on in future courses. Another goal of ours was to focus, show students how some of the next generation cross-cutting concepts like structure, function, and patterns could sort of like merge with issues of computational thinking. But we did all this within the context of a project-based learning arc in which students actually found and engaged with topics and problems that were relevant to them. And in the process of working through these problems, they decided to design digital artifacts that require coding and programming and computer science skills. But so students, the entire instruction really is based on something that is highly engaging for the students, because the students are able to select this sort of like really, really important problems to them that they're either at a personal level or a social level or a cultural level or a community level. So we are, by doing this, we also engage in what we call culturally authentic practices, which are sort of like tagged along completely with the project-based learning aspect of the course, and allow us to promote as students to build agency, build on the strengths that students already have and they're bringing into the classroom, provide an equity building collaborative work opportunities for them, and also have in sort of like components that help them feel that they belong in computer science, and so that they don't necessarily feel that that is an area which they do not belong, which is sort of like within the realm of what we call reducing social identity threat. And I'm going to define this for you just right now, if we just move to the next slide. Because, sometimes when we're talking about all these concepts and topics, it may not be entirely clear what we mean by all of them. So when we talked about asset-based thinking, we're actually referring to practices that help us focus on the skills, the knowledge, the perspectives that students already have, that they're bringing with them from their families, from their groups, from their own life experiences. As you are going to see, many of the topics that students select have issues related to mental health. We know that this is a huge issue for students and our younger generations. So they may either themselves or somebody that they know, a peer or a family member, suffering from mental health issues. So they have the opportunity within the classroom to sort of like come in and explore that problem and help raise awareness about it and educate others about it. So we try to do something that really builds on the strengths and the knowledge that our students already have. And all the students already have a lot of things that matter to them and that they're important to them, and that they have a lot of skills and knowledge already built around those issues. The other big part is that because the way that we work on the problem allows the student, like I mentioned, not only to research that problem, but to put together digital artifacts that serve to create awareness about this problem and also showcase solutions to others about these problems, students have an opportunity to experience agency. That means a sense that they can really change something through their actions, that they can be effective in having some positive outcome if they actually educate and inform others about the things that matter to them. And we know that this is very important for students to feel that they can be efficacious and that they have like a sense of belongingness. within the spaces that they inhabit, particularly in the classroom. We also do a lot of collaborative learning with the CAPACiTY, so this is another big part of our framework. And we know that sometimes that may look slightly different in computer science, but we want students to have this professional and real life idea of how much of this work really happens, and have also students have the opportunity to experience different coding roles and creator roles, so everybody gets to know what it are the different skills that computer science actually really entails when you're creating a website, when you're developing an app, when you're making music and coding. So a lot about this collaborative learning, actually, it is very well designed to promote equity within the classroom and allow students to explore these different roles. So it's very purposefully designed, not just so the students work in groups, but that the group work allows all the students to sort of like explore these different areas. And lastly, the other big practices that they're part of our culturally authentic practices is it's focused on social identity thread. We know that especially underrepresented minorities and girls, there's a lot of negative stereotypes that are pervasive within computer science and other STEM fields about their success and their representation. So we really knew that we needed to do something purposeful and intentional to help students develop a more positive sense of identity towards computer science in general. So our curriculum really has a lot of practices and techniques that help expose students to other relatable role models, students that look like them, that they're already in college, exploring computer science, and that they very recently may have been just like them, you know, struggling with math, not knowing what to do when they went to college, and they were still able somehow to sort of like find their way within computer science. We also help students have these reflections of their learning so they can see their learning grow within the course of the year, and then they can build a sense of competence and this sort of like incremental gains within the field all throughout their experience within CAPACiTY. So all in all, like I mentioned, you know, we have those big 4 components: a focus on computational thinking, next generation coding concepts, and all this is built pedagogically within an arc of project-based learning and culturally authentic practices, which are mostly focused on asset-based thinking, agency, collaborative learning, and social identity thread. Now, how is this connected? Many of these practices are actually very well connected to our best practices for culturally relevant pedagogy. If we can move to the next. When we actually looked at social justice frameworks, and like the frameworks is particularly culturally relevant pedagogy, which was developed by Latson-Billings in 1995, Latson-Billings really actually advises and focuses on our understanding of how we can really focus, first of all, on student academic achievement and success, which for her really meant a long-term learning indicators within the classroom, not test scores necessarily, but seeing how students build that sense of competence and the skills that were necessary for them to succeed within the particular discipline that students were studying. Another focus of the theory, it is developing a cultural competence, which is how we can create appreciation and learning of other people and other cultures, and create in the classroom a place where that has a value and that has a presence. And lastly, sociopolitical consciousness, which is an understanding and the critique of all the current and social inequalities that students and people may suffer and, you know, in society, and how we can use that knowledge that we're acquiring within the context of a particular field or discipline to actually solve a lot of these real life problems that students really feel that they have. So for us, a lot of the practices that we already have, both from culturally authentic practices, but also from project-based learning and motivation, really map very well with this 3 main components that we see within culturally relevant pedagogy. First of all, we know that project-based learning, and especially a focus on computational thinking and next generation cross-cutting concepts, together with a focus on giving students best practices within motivation theory, really are the best tools that we have pedagogically to promote a student academic success. Why? Because they focus on mastery, because they focus on deep understanding and deep learning, not just on rote learning or like practice, and because they really sort of like have sort of this progressive sense of allowing students to gain deep knowledge within the context of giving them a voice, autonomy, and let them build a sense of competence. And we also believe that a lot of our culturally authentic practices, especially, agency asset-based thinking, equity-focused collaborative work, and our interventions for stereotype threat also align very well with this notion of helping create in the classroom a sense that students' issues have value, that the real life problems have value, that we can acknowledge the historical and the sociopolitical things that affect them if they would like to talk about those topics or bring those topics into the classroom. But we also acknowledge that a lot of the personal things that look very, very individual that the students bring into the classrooms, they have a lot of layers that have to do with their own culture, with their own groups, and with their own concerns, not just as individuals, but as members of these all different groups. So this is why we believe that our curriculum, it is actually pretty much still within the realm of hitting all these important goals that we know are necessary in order to have a pedagogy that we know it is culturally relevant and authentic to people. So the next part of our presentation, I'm going to pass sort of like the mic to Doug and then later to Pam, so they can tell you with a little bit more detail how do the curricula that we have created within Capacity using these principles and these frameworks actually look like, and what do they include?
All right, can you hear me?
Yeah,
Great.
We can hear you, Doug.
So if you go to the next slide, Pam. So the Capacity Introduction to Digital Technology curriculum consists of 4 units. You can see the units in front of you. The first unit is focused on media literacy, and the students develop a PowerPoint presentation around the topic or problem that they chose that was relevant to them. And as a part of this first unit, they actually do research and understand what's the difference between a credible website and a not so credible website is, as well as actually have scaffolding to actually select that problem that they are going to do. And they do this work in a pair, and each has responsibilities in that pair. They also narrate that PowerPoint presentation with the goal of their narration to be to inspire another pair to leave their problem and come over to your problem. So that in the classroom you end up with approximately, say, 5 to 8 problems within a class of 25 to 30 students throughout the class. Because as those pairs become groups of 4 to 5 or 6, then those groups of 4 to 6 will then do further research and build website pages together to bring awareness to the problem on the web and advocate in respect to the problem. And as a part of this unit, the second unit on web design, they look at empathy. They see the web pages as narrative, so they're telling a story to engage the person who is viewing their website. In this unit, they will apply HTML and CSS, integrate a video, understand basic networking principles in terms of taking a look under the hood as to how the work they are doing in HTML and CSS, how it goes from their computer to a web server and onto somebody else's computer. And they understand some basics in cybersecurity and cybercrime. And then in the third unit, they use EarSketch to program and code music in Python that they will put in the background on their website to engage the person viewing their website even more. And last, they build a mobile game app using App Inventor so that, as an example, they could do a game where they collect the main character from their narrative collects good things related to their problem and avoids the bad things. And I'll show a couple of screens of examples of that in a moment. So next slide, please. These are examples of what students did. So you can, they chose things from car accidents to mental health issues of anxiety and stress, bullying, which you don't see on here, school shootings, police brutality, family being separated at the border, college debt. So the topics that students see as relevant to them cross the gamut. You go to the next slide. And so when they coded music for some of these topics, just using these three as an example, for the car accidents one, here's the music that students coded. So in there, I'm pretty sure you can tell where the car accident happened. But they were giving information and research as to how music can affect mood. And so in terms of tempo and pitch, and in the anxiety and stress, they had to define, all student groups had to define their intention in terms of kind of emotion to elicit. So they said people tend to think of anxiety and stress and be sad. So they wanted music that was more upbeat. So here's the music that they had for anxiety and stress. So as you can see, it was much more upbeat. They said they wanted people to read about anxiety and stress and come away feeling better in respect to once they read the information on ocean and marine pollution. So that beginning sound, they said, was like an ocean wave. And with respect to that riser sound, then they wanted people to have a moment of being thoughtful. And so they went from there into, once again, something upbeat. Go to the next slide. And these are some examples of their game apps using App Inventor. In the previously in EarSketch, from a computational thinking standpoint, they focused on variables and iteration. In App Inventor, they focused on event-oriented programming and conditionals. And you can see in terms of the police brutality app, their goal was to avoid the police in terms of dealing with issues that can relate to brutality. And the other screen you see here, that was a school shooting app. So what would happen during the game is the background would change, and depending upon the background, you would grab these student characters and bring them into safe backgrounds and keep unsafe backgrounds. And so if you go to the next slide. And so we did a supplemental request to the National Science Foundation. And in that supplemental request, we ended up developing other curricula. And we took what we did for IDT, which is a 9th and 10th grade mainly oriented curricula, and modified it toward middle school and modified the framework toward AP Computer Science Principles. And we also did an IDT CSP combination and an IDT with math support, but we're just going to share the middle school and the AP CSP. The next one. And in terms of the middle school, so there are 2 middle school curricula we designed. One is Foundations of Interactive Design. It has 3 units. It's designed to be done in 1 semester in middle school. Once again, students choose a topic that is relevant to them. They design a website. In this case, they only use HTML. They use Google Sites and integrate a video and learn a little bit about data security and privacy. So you can see there are fewer topics that they deal with under web design. And as far as the intro to game design, in that case, they use Thunkable. And they use Thunkable to do a game like what I talked about earlier, where they collect good things. The main character collects good things related to their topic and avoids bad things related to their topic. And if you'll go to the next slide. And for Foundations of Design, these are examples of what middle school students chose as topics. In a Metro Atlanta middle school, when we piloted with them, so they chose racism, LGBTQ rights, human trafficking, immigration reform, homelessness. So as you can see, students have some very serious issues when you ask them to choose what's important to them. And so they developed their websites and games around these topics. Next slide, please. They also did a 4-unit, 1-semester course, Foundations of Computer Programming for middle school. Once again, students define a topic. Then they make a musical intro in here sketch and a musical background for a quiz game. And so in the intro to app building, they make a quiz game in Thunkable. And after that quiz game, they do a MicroBit piano that they can add music into the quiz game, or they can add music into ear sketch and remix into that and add that back into their quiz app. And so those are the middle school courses. Next, please. Next slide. And the MicroBit Piano, there's an example image of how it looks using the MicroBit with the alligator clips and so on. And so they make an actual piano scale of 7 notes using the MicroBit to explore the integration of hardware and software. And next slide. And I'll turn it over to Pam for APCSP.
Okay. All right, so now I got to run the slideshow and talk all at once. So we'll see how this goes. So, you know, we wanted to take this capacity philosophy and make it work for AP Principles. And if you're familiar with the AP Principles curriculum, it is quite large. There's lots and lots of standards that we're supposed to go through in a school year. And some of it can be quite abstract and quite dry. So we wanted to come up with a way that we could make this more engaging and more relevant for the students and give them a personal connection to it. So we took this concept of an arc, whereas in middle school and in the IDT course, they're selecting a problem that they're interested in. So for AP Principles, we kind of take it a step further and have them select a computing innovation, because one of the core components of AP Principles is that the students have to identify computing innovations and really do some deep research into, what is the intended purpose of an innovation? What are the beneficial effects, harmful effects? What is the impact? How is data being used in the innovation? How's it being kept secure? What are the legal and ethical and privacy issues related to the data that's being collected? So what we did was, instead of selecting a problem, the students are selecting an innovation that they're interested in. And then once they do that, they are looking at what, innovations occur because you're trying to solve a problem. So what was the problem behind this innovation? Where did this innovation get started? So the first thing the students do in this course is they go through a process of selecting this innovation that they're very interested in. And that's what Unit 1 is. They're going through this guided process of, brainstorming all these things you're interested in, researching the innovations that are connected to them, narrowing it down to something that you are truly authentically interested in learning more about, and forming collaborative teams around that. And then in Unit 1, the students, so for every unit, we have a challenge that goes along with the content. And that challenge ties the content of that unit back to this innovation that they've chosen. So the arc is kind of this overarching thing that we learn all this content under as we're going through the curriculum. So Unit 1 is focused on topic selection, and they're building a website to educate the public about this innovation and the history of it. Unit 2 used to be called Internet, now it's called Computing Systems. Unit 3 is Network Security. Unit 4 is Data Abstractions, and Unit 5 is Big Data. And this would make up the fall semester. In the fall semester, under each one of those units, they're doing these challenges that, like I said, tie back to the curriculum that we're learning and also the innovation that they've chosen. So the first one for Unit 1 is where they're selecting the topic and the innovation and forming their team. Unit 2, when we're learning about the internet and how it works, all the networking skills, they're also doing a business profile of the innovation, really digging into what is the company behind the innovation, how many employees, what are the demographics, where is it located. So we're bringing in some business skills there so they get an idea of who's behind this innovation. Unit 3, which is security, cybersecurity, then they're really digging into that innovation and looking at what is it doing with the data it's collecting, and is it doing it in a safe manner? They investigate the laws that are applicable to that innovation. They're looking to see if there's been any data or security breaches with the innovation. So they're doing some research along those lines, which is a very current and relevant topic these days. And then in Unit 4 and Unit 5, they're really focusing in on how is that data being transformed? What is it being used for? They're creating their own citizen science experiment to gather information somehow related to this innovation, and then saving that data and analyzing it and filtering it and trying to make some conclusion based upon the data that they are collecting. And this is just sort of a summary about those challenges. Each unit challenge has an artifact product that the students are creating in these teams. So they're collaborative things. The first unit, again, was that website and also a quiz game where they can educate people about their innovation and the associated problem. The second unit has that business case study. And once they learn about the company, then they're going to create a digital recruitment artifact to try to convince people that this company is where they would want to work. In unit 3, which was the cybersecurity unit, after they've studied the security of the innovation, whether there's been any breaches, what are the applicable laws, they're going to create a PSA about those laws that's relevant to the innovation. And then unit 5 is that data collection and analysis of the data that they've been, collecting for the last probably 8 weeks of that semester. One of the things when I teach AP principles, I could not imagine teaching this class for an entire semester and not doing any programming. These kids are anxious to jump in and do some things. So what we decided to do was have optional coding plugins where you can bring in a little bit of basic coding within each of those units in the fall semester. It gives them a really strong foundation going into spring semester where you're getting into some more of the rigorous coding. So each unit has this optional programming element that you can add in. Unit 1, they could make that quiz app using App Inventor or Thunkable. Unit 2, they create music that goes along with that recruitment artifact. Unit 3, they can extend that initial quiz game to include some information about cybersecurity. And then Unit 4 and 5, they could do a couple of things. They could create an e-card that invites participants to take part in their citizen science experiment, or they could use the App Inventor database and actually create, a replica of like a Google form and save the data so that they could use that to analyze. So these are all optional things. And the thing I like about the optional ones is if you've got some, high-flying students in your class that are already coding in another language, you can modify these and allow them that flexibility of working at the level that they're at. So it really helps personalize and meet students where they are. So this, when you get these slides, this was an example of one of the websites that my students put together. At this point, we're running a little short on time, so I'm just going to skip over that. But the students add to that website all semester, and it's where they showcase these unit challenges and these artifacts that they're building. That way, at the end of the semester, we have a big gallery walk that showcases all of this work that they've done. One of the most important things is allowing students to pick the things that interest them. So, I typically teach 3 sections of AP Principles. And so this was sort of the range of topics that my students chose. And I think when you give them the opportunity to pick something that they're truly authentically interested in, it increases your engagement so much because they're interested in it. And then you're showing them different facets of this thing. It's not just an innovation that you're going to go buy. What is the problem it's trying to solve? Who are the people behind it? What are they doing with this data they're collecting? So all of that content that we're learning from the standards in AP Principles, they're applying under this topic that they're truly authentically interested in. And it makes it more fun for me because I learn a lot about these things right along with them. So it makes the class more fun and more engaging, not only for the students, but for the teachers as well. Programming and capacity, we definitely want to do project-based. We want to allow students to be creative and personalized. And instead of teaching them all the content, and then once they've learned it and passed a test on it, then they get to build a little program where we know what we're looking for. We're letting them design projects. We're letting them have a lot of voice in what it is that they're doing. And it just makes it more relevant, and it keeps them engaged and keeps them, that student agency that we talked about, it gives them responsibility, and it makes them have more pride in what they're doing. Typically in AP Principles, we use EarSketch for a good bit of the program. Some teachers use Python, some use JavaScript. That's completely up to the teacher. We also use App Inventor or Thunkable if we're wanting to do some of the more visual games. We also do some just pure Python coding. So you can kind of do a lot of different things. A couple of times I've given students options, and I would have different groups doing different platforms in my classroom at the same time. They were all learning Python, and pulling in some MicroBit when we can. So again, you get a lot of flexibility while you're learning the stuff that you're supposed to learn. And here's just some screenshots of App Inventor. Ear Sketch, Doug talked about a good bit. The students love that. They can just make some music, download the MP3, have it on their phone, make it their ringtone. We had a contest to see, we came up with a class ringtone that I would play when I was ready to start class. And so, we voted on which one they liked the best. And we'd have a fall semester one and a spring semester one. So it was fun. Anytime you can make it fun, it's worthwhile. All right. So that's the official presentation, folks. So what questions do you have for us? Anything in the chat over here?
Yeah, this is your time to ask us any question.
Okay, I'm going to stop sharing. That way we can see each other. There we go. Okay. One of the things that we've talked about in some other meetings was just the power of letting students make mistakes and then learn from them. And we've noticed this across all levels, middle school, IDT, AP principals. Students come to us and they're thinking that if they don't get it right the first time or they don't get it quickly, that they're not any good at computer science. So part of this project-based and having these different platforms and allowing them a lot of choice in what they do is just showcasing for them the iterative nature and that everybody makes mistakes and we can improve and we can keep moving. And that it's not always checking things off a list and getting the A. It's finding something you're passionate about and building stuff related to that. And it kind of breaks that mindset a little bit.
And a lot of the learning reflections that we have built throughout the course, they are really also pointing out to the things that students may not always think about their learning, like what have you learned about your group work, sort of like during this unit, by working in pairs, or working in a group, or by switching roles. So there are opportunities for students to sort of like really drill down what it is that they're learning, not in computational thinking terms, in terms of programming, in terms of coding, in terms of accomplishing things with the activities, in terms of, digital artifacts, like I learned how to do a website or I learned how to make an app, but also in terms of like, what are the gains in working with others, in sort of like advancing an understanding about an issue, in learning how to connect with others, in learning how to design a product and thinking empathically about your audience. So all these different pieces are sort of there for the teachers to really hold on to if they want to take real advantage of that.
I think that's a really good point you made, Diley. One of the things that I learned this year, this past school year with COVID has been quite a learning experience. So, I had students that were all remote. Then I had some students in person and some that were remote. And we all had to change the way we teach. And I also teach the Java class, AP Computer Science A. And in that one, I was never thoroughly open to group work because I wanted them, I wanted them to learn. I wanted them to focus. And we did a significant amount of partnering and group work in the Java class this year. And I think it deepened the learning that they had. So it really changed my perspective on the power of collaboration and how it makes everyone better. I think the worry that a lot of teachers have is that if you have a partner or you have a group, one person's going to do all the work and the other ones aren't going to learn. But my perception of that definitely changed this year. And I saw it be good for all of them. And it was pretty powerful. So it's quite a learning experience.
And I think one of the hardest things about when you in general have project-based learning, but especially a lot of group work associated with project-based learning, is that you had to develop a certain level of comfort with letting go of controlling too much, which is that the groups work better when there are things happening, when the groups are loud, when they're messy, when they're working together, when they're sort of like plugging in. So sometimes that goes against some of our more strict notions. So what should be happening in the classroom? Maybe they should be silent. Maybe they should be organized. Maybe they should not be walking around. But so how does a classroom in which you have this very active, engaging group work and students thinking and students discussing together and students sort of like trying to come out with rich things, while at the same time then they're later sort of like coding together as changing. So I think that it takes a lot of, I think for everybody who has ever taught, it takes a level of comfort of getting used to giving away a little bit of that control and embracing that thing that in the way that superficially looks, it makes look messy, but it's really rich inside what is really happening for students in terms of what they're able to do with each other when they talk and they engage actively with each other.
Right. Absolutely. My class is always loud and, people are talking. They're moving around, helping each other. When we're coding, somebody has a problem, we can't figure it out. We're calling other people over to look and do some collaborative debugging. And it deepens the learning that's going on. And I think it's why when you teach that way, you're absolutely exhausted at the end of the day because we never sit down. We're always moving. Yeah. But it's pretty powerful, and the students enjoy it, and they don't tend to fall asleep, which is always a problem in 7th period.
Yeah, like Terry was saying in the chat, it's control chaos.
Yes, those are my favorite kind of classrooms. Like if I walk into a classroom and it's quiet, something's wrong.
Right. Yeah,
control chaos. I love it. Loud too. Yeah, Dawn says loud too. That's right.
Yeah, I was lucky. My classrooms always have been at the end of the hall, so I don't get shushed very much.
Awesome. Any other questions from the participants? Awesome. Can you all please post a link to the slide deck in the chat? We're combining all of the presentations and resources into one document that we're going to release later this week, if you don't mind.
Diley, can you do that since you have or do you want me to?
Yeah, but I don't have it in Google, so do you need like a Google link?
Sure. Or you can email it to me and I can.
Okay, I think then. Oh, I see Doug working on it. He's saying something. Hold on.
Okay,
I can do a quick coding link.
I'll put my email in the chat. If you just email it to me at a later time, I'll convert it.
Perfect.
Or any other resources, any links that you have to any other resources that you talked about today, you can send me that as well.
Yeah, and like I mentioned, and I posted this on the chat, if anybody's interested in having access to the CAPACiTY curriculum, they can email us at capacity@edu. So it's free, it's accessible to the public. We just need to sort of give everybody access.
All righty, well, I think that ends our session. Thank you so much, Douglas, Pamela, and Diley. Did I pronounce that correct?
Diley.
Diley, I'm so sorry, Diley. Thank you so much to the three of you.
Thank you so much for helping us and moderating.
Thank you, Terry.
Anytime, anytime. Look forward to hearing from you all soon. Take care.
Bye-bye.
You too. Bye, everybody.
Bye.
All right, you too. Bye-bye.